Picking up. Hello, can you guys hear me online? And you hear Yuchao?
Hello, can you hear me? Great, they can hear.
Awesome. We might have to yell in this room, I guess.
Don't want to use that one?
We can, but then we'll have to hold two microphones. So I don't know if you've got a loud voice. You
I will try.
Go to practice. Or we can turn this on
Should be fine.
for the welcome.
Hello.
Cool.
Welcome everyone to COMP1531.
Yeah, okay, we're starting? All right. Okay, so as you might have, if you were here early, you would have seen the 3 AV engineers trying to fix this room. So we've got it sorted though. So if you can hear us online, please let us know. And if you can you hear us in the back as well? Yeah, some nodding. Okay, cool. Well, so as Yuchao just said, welcome to COMP1531. We finally made it. We're really, really excited to work with you throughout this term. Who's in second year? Is it most of you? Yeah, most of you. Who's in first year? So you started like T2 last year or something like that? Cool. So the idea of this course, let's not go there yet. The idea of this course is to take you from someone who's done something like 1511 and to start introducing concepts of software engineering. So what does software engineering mean to some of you in the room? You can yell, shout out, put up a hand. Or actually, whose first in-person lecture is this at UNSW? Okay, some of you have had some. All right. So you know how this works. So what does software engineering mean to some of you? Say that again? Yeah, exactly. So to write a program that solves a problem or fits an aim, yeah? Anyone else? What was that? 6-figure job payment, yeah, the money. Yeah, that's part of it, I guess. Feel free to come in if you'd like, at the door. Yeah, so, don't be too embarrassed. Yuchao, what does it mean to you?
Well, I think it's modern programming. So this is my understanding. It's a step forward from 1511. So not only we are learning programming, I think, so we are also learning some other things like, what is it, group work?
Yeah, writing code in teams is probably the big change. Writing larger systems. So if you think of something like 1511, you write small programs, right, that solve a particular problem so that you still got a goal. But when you start going into the software engineering world, these are huge systems, some of these systems. Think about all the different software systems you interact with. If you're on YouTube right now, think of the millions of lines of code powering YouTube and all the different hardware data centers and all the software that runs at those data centers. How do you make sure every piece of that massive puzzle works? That's, to me, is what software engineering is. You can't maybe you can, but you don't really software engineer on your own because the scale is just so big, you need a team. And then once you start introducing teams, you have lots of problems. Like, how do you manage source code in teams? How do you make sure that everyone's able to be productive every day? How do you make sure people can communicate their different ideas correctly? How do you manage all the projects? I mean, this is all what software engineering is.
Yes, I do agree. Like project management, teamwork is a very big part of software engineering.
Yeah, exactly. Okay. No, you can stay for this. So we have to do it's a bit boring, but we have to talk about some of the structure of the course. So we have the lectures. If you're in the room, welcome. And if you're online, welcome. I can't believe it's all working. We have the weekly tutorials. Who went to the Monday Tute Lab? There was 2, I think. Who's been to a tutorial yet? No one?
There.
A couple people. So you have your weekly tutorials and labs. That's just exactly like 1511 or most CSE courses, right? Something probably new to all of you is this major project idea. So rather than 3 assignments or something like that, Majority, I think, is it 90%?
Yes, 90%.
90% of the assessment in this course is coming from this major project. This major project is a group project. However, it's about 50-50 group assessment and individual assessment. And all of the information about the group project will be discussed really soon in your tutorials and in the lectures as well. And then we have some help sessions. Just, if you've done 1511, you know exactly what those are about. You can drop in when they're running, get help from a tutor, and get back onto your day, basically. And yes, of course, it's been spoken about in the welcome video and online and on Discord. There's no exam anymore for COMP1531, so it's a full project-based assessment. Yes, good? For help sessions, as it's group work, should we go as a group? You can, but you can also just send someone. It's okay as well. So, getting help. So, this course is a step up from Intro to Programming. We're not out to kill you, but it's just as we get into more complex topics, things get harder. And actually, something that happens is that you will start coming across problems that maybe we haven't even seen before, or we won't instantly know the solution, because we're starting to get into more complex systems with a lot more moving pieces. It's likely that the challenges you come across are probably a little bit more challenging than something in like intro programming, where it's a very controlled environment. So it's worth saying, okay, what should you do when you get stuck? Because everyone will get stuck on something. Well, you're in a team with your group members, so speak to them. Do you want to, what next, Yuchao? You could go to the forum.
Yes, everyone should be already in the at the forum. If you are not, please go to the web CMS. There's a link at the left-hand side in the menu. So you can go to the forum, ask any questions that you encountered. Our teaching team will reply to you and answer your questions as soon as possible. So we are amazing, like we have more than 40 tutors and admins. So we are a team of people like helping you. So
yeah, exactly.
Yeah, so you should feel free to be like ask questions and you'll get support.
If that doesn't help, you can email your tutor or your lab assist, and then finally you can email us. A few of you have emailed me at my personal email, or maybe even Yuchao, but it's better to use this alias because then we both get the email. Cool? Okay, so once again, well, maybe some of you don't know this actually. The language that we're primarily dealing with in this course, actually two languages, is JavaScript and TypeScript. It's an interesting sort of discussion why JavaScript for a back-end course. There's a number of answers. Primarily, I think, because the course used to be in Python, if anyone's been paying close attention. One of the reasons is that if you look at what is happening in industry, JavaScript is becoming the dominant language even for back-end engineering. Does anyone have an idea why? Say that a bit louder. Yeah, I think that's the answer, basically. And so let me repeat that for people online. So all front-end development is JavaScript-based, right? We can all agree on that because browsers run HTML, JavaScript, CSS. At the end of the day, there's lots of fancy tools and things, but they get compiled down to JavaScript, which is running in the V8 engine, for example, if you're using Chrome, and that's what powers the logic in web applications. Back-end systems can be written in anything, right? Anything that runs, they're just programs, so they could be Python, which is what we used to teach this course in. Mm-hmm. You could have a C++ backend, you could have a C backend if you are so masochistic is the term, I think. But I think what's starting to happen is JavaScript has gotten more mature as a platform. Engineers and teams have realized, hold on, if we're writing all this JavaScript for the front end, if we write our backend in JavaScript as well, we unlock a number of benefits. You can reuse your type system. All your tooling is the same. You don't have to add another language, so it's easier to train people and to write the code. And so what's happening now is that JavaScript, even though you've probably all seen memes about JavaScript being yuck language. Has anyone seen stuff like that? You know, comparing a 0 to a string 0 and then it says true and things. So even though JavaScript is sort of does, and that is true, I mean, it's got some weird properties because it was made for the web. Even considering all of that, it's still dominating as the backend framework of choice. And so that basically is what motivated our decision to switch COMP1531 to JavaScript. It's because most new backends are being written in JavaScript sometimes. Like something like YouTube isn't going to do that because they need to be really fast.
Yeah, and I think another thing is that I think in the old week, welcome to the new students. Like our new head of school, Soumya, also mentioned that the programming language is always changing. So as long as you learn the basic, it's very quick to learn another new language. So yeah. So if you want to learn more about other language, like when you learn C in 1511 and you learn JavaScript in 1531, it's a lot easier to learn other programming languages.
Yeah, exactly. Now, so the first thing you should probably do once you've got access to the course website and the forum and everything is get your local environment ready to go. And we have a guide on how to do that on WebCMS. So if you go to WebCMS and you click Getting Started, it's just a delay, I think.
Okay.
Yeah. So if you go to WebCMS and you click Getting Started, and for some reason it's slow, but here's one I prepared earlier. We have some instructions for getting Node.js installed locally. So one of the first things you should do is, if you haven't already, is to run through this Getting Started guide and get set up locally. This works on Mac, Windows, Linux, whatever, probably your smart fridge, maybe. Okay, a question. Oh, I remember you, AR11 from T2 last year. Is it recommended to use VLab? Okay, this is another big change if you've come from 1511 and other courses at UNSW. You're now software engineers, not programmers. I don't care what environment you use, as long as it's your responsibility to make sure your version of Node is correct and you're comfortable with your setup. If you're comfortable with your setup and the tools work, we're happy. You know, it's not my job as an engineer. Like sometimes software engineering teams will say, yeah, you got to use this version of this and you got to use this tool. But if you're a Mac developer or you're on a Windows device, that's up to you. So if VLab's more comfortable for you,
can you guys hear me online?
What's going on there? If VLab's more comfortable for you, you can use that. And sometimes it's a bit easier because if you've got lots of different devices, you can just access that, you know, from each device. But I personally develop locally on my Mac. A lot of the tutors use VLab, for example.
And if you use VLab or your local environment later for other courses as well. So if you set up the environment on your laptop, it will also help with other courses in the future.
Yep. Okay, cool. So that's the Getting Started guide. Okay, so we've sort of briefly discussed some of this. WebCMS is the course homepage. You've probably used this before. I know some of you are new to UNSW. Does everyone have access to WebCMS? Everyone better put their hand up. I'm not. We don't, I mean, if you've got access. So does anyone not have access? Maybe if you enrolled late or you haven't checked, maybe? Okay, that was I must have missed a category because that was not totaling 100% of the class. But WebCMS is the course homepage. Please, you'll be using that for all the announcements that get emailed to you and all of that. EdSTEM is the forum. There's a link in the sidebar of the course website to the forum here, and that'll take you straight there. Okay, GitLab, which I'm going to talk about more shortly, but for now I'm going to skip over it. If you're in an online tutorial, your tutorials will be on Teams, and the help sessions, the online ones, will be on Teams as well. And there's a Teams group made, so Teams is for any online stuff, basically. And we're using Git, which I'm going to talk about today, and Node. Does anyone know what Node is? yeah, it basically like, remember I said JavaScript runs in the browser as so the browsers have these JavaScript engines that runs all the JavaScript code that runs on websites. But if we don't have a browser, we need some other tool, right, that can understand and execute JavaScript. And Node is a non-browser based JavaScript engine that uses the same underlying JavaScript engine as Chrome, the V8 engine, but it runs command line. So this is like your compiler for C, for example. They're the main two pieces of technology so far. There's more coming later. So I made a little checklist here. Maybe you want to take a photo of this slide. So make sure you can access WebCMS. That's really important. Please read the course outline. It's got all the nitty-gritty details on the assessment structure and how it all works. And it'll save us lots of emails if you... and if we need to update something, right, it's just better to go straight to the source. This one's really important. It always shocks me, looking at the statistics, how many hundreds of students don't access the forum until like midway through the course. It is by far the richest resource to get you through this course, because every question that students have get posted to the forum, and you can read all the answers for free. But hundreds of people don't access it. So make sure you click the forum link and access the forum on EdSTEM. Go through the Getting Started page on WebCMS and make sure you can access GitLab. So just make sure you got access to everything. Anything else, Yuchao? What are we missing?
I think
pretty good so far?
Yeah.
Okay. That ends the actual boring stuff. So actually, the other thing worth talking about in terms of the lectures, so obviously there's two of us. We didn't really introduce ourselves, actually. We should do that now. So I'm Jake Renzella. I've taught 1531 before. Maybe you've seen some of the lectures the old lectures on the YouTube page. I guess a little briefly, why are we teaching this course, or why am I teaching this course? So let's see. I used to be a software engineer in industry. So I worked at a software lab that became an institute, actually, and I did engineering for AI. So if you think about having these AI or data science teams, you need lots of software engineers to actually make everything work. In fact, I think software engineers are the most important part of AI still. So I was a software engineer in that context, and then I was a software engineer for defense for about a year, which, yeah, that was good. And Yuchao?
Hi, I'm Yuchao Jiang. Actually, I'm new to 1531 and also new to CSE. But I really love software engineering. So this is why I was so excited when Jake invited me to co-lecturing 1531 this term. And I will be teaching 1531 in future terms as well, I think, hopefully.
Yeah, so so some of you might not know, this is a massive course. There's about 700 students, even though it doesn't look like it. But there's like 100 or so online, and then a lot of people will watch these lectures later. And it's a pretty complex course to run. So that Yuchao does a great job in the future terms, just like I did last year, I think. We're co-lecturing this term, and then that's how we sort of do it. The actual structure is that we'll basically take turns. So I'll give, I think, the first two weeks of lectures. Then
I will jump in week 3.
3 to something, and then I'll be back. We'll be around. You'll see us both. But you know, all the slides and the content is the same, and all of that's the same. Yeah, so that's the overall structure. Just to reiterate, we're both really, really excited. We have a lot to get through, but it's really interesting stuff. And this is where, you know, you start taking what you've learnt in 1511 and you start being able to really build cool stuff. And then you'll start clicking and thinking, oh, I could make an app that does this, and I can make money with a system that does this.
Yeah, exactly. So my PhD was in software engineering. So it made me so excited that softwares that make our life so easy, like much easier than before, like with softwares. So so be excited, like you are becoming a software engineer. So
that's right. Think of how bad the pandemic would have been if we didn't have YouTube. You survive? I wouldn't have. Okay, thank you, Yuchao. Yuchao's going to hang around, and then we're going to get on to some of the content. You can still hear me online, I hope. let's see. What's going on? There's some chat here. I don't think anything too... Yeah, web CMS is slow at the moment. Okay. All right, so what is software engineering? We sort of spoke about this a little bit. This is my, the Michael Scott from The Office when he starts giving that wedding speech and gives the definition of marriage, that it's the welding of two metals. Does anyone remember that scene? No? Well, this is the technical definition of software engineering. The application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software that is the application of engineering to software. What an awful, awful phrase that is. To me, it's a lot simpler. If 1511 is learning to code or learning to write code, 1531 software engineering is learning to design, architect, test, and build large software systems in teams. I don't think that's in there, but that's the key part. You're working in teams. What's the difference to computer science? Computer science is understanding how computers work, right? All the way down to the hardware level, potentially, making computers do things. Software engineering is much more human, I think. That's the big difference. Software engineering is saying, there's a group of people that want to be able to do something that they can't currently do, or there's an opportunity to solve some problem, right? It's an abstraction on computer science, I think. It's closer to even business and marketing. It's thinking about what do people want to do better than they're currently doing, and making the right software at the right time, in the right time frame. That's the other thing. And making sure it's maintainable. Like we have to juggle so many things with software engineering, and making sure that it grows as our users grow and things like that. Software engineering is, so who thought programming in 1511 was difficult? Who thinks programming is pretty challenging? Oh, very confident. Okay, yeah, it's pretty hard. It's one of the most failed first-year courses at university globally. I think psychiatry is more failed because they've all failed the statistics course. I read a paper on that once. But it's pretty tough. Software engineering, I think, is even tougher. So if you think of every software company out there and all the different software engineering projects they embark on, what would you guess is the percentage of projects that succeed? 1%. Okay, it's not that bad. Otherwise, we wouldn't have a job. It's about 50%. So 50% of software, so 50% of the projects Google undertakes will fail. You'll never hear about them. They will fail before they reach, or maybe even after they reach users. I mean, no one would have tried Stadia. Google killed that in less than a year. Would you call that a failure? A very expensive experiment? Maybe someone in that team maybe calls it a failure. What are some other software failures? Let's see. Anyone got any ideas? Google Glass? Yeah, that was a big failure. Oh, Google Plus, was it? That was a failure. Now, this is interesting because technically Google Plus worked. It's not like you logged in and it crashed. Maybe it did a little bit, but right, we agree. These systems worked technically. Computer sciencely, that's what it was, they worked, but maybe users didn't like them, or they weren't fast enough and people switched to a competitor or something like that. This is what makes software engineering really, really hard. You might you might solve the problem and no one will use your app because you took too long to make it and the moment died, or because it's too expensive to run because the way you architected it was inefficient or something like that. Cyberpunk, yeah, that was a failure. Games are really hard. It must be way more than 50% for games. So software engineering is really hard, and trust me, I can't tell you enough how hard it is. When you go work in industry, as most of you will, I'm sure, as software engineers, it's really fun, but I think most projects I worked on never got released, if that makes sense. Yet, we still have jobs somehow. So do you need to be a software engineering student to be a software engineer? Who's enrolled in software engineering? And who's enrolled in computer science? Yeah, most of you in computer science, and most of you will go off to be software engineers, right? Typically. So in terms of the actual courses, there's very little difference. There's some semantic differences and some structural differences. And if you're a software engineering student, you've got to do a fourth-year honors with an academic like Yuchao or myself. But typically, a good computer science student or a good software engineering student is very, very similar. It's hard to tell them apart. I was a computer science student, if that makes anyone feel better. And there's a large variety of roles out there. And I'll just use this. Hello. Okay.
Like in the meantime, any questions?
Okay, I think that should be okay. All right.
Working again?
Yep.
Great.
Hopefully, audio back. Good. Oh god. All right. See, software engineering's hard. Hey. So some places that you go to work in industry as a software engineer will specifically hire you as a front-end engineer or a back-end engineer. Some places don't do that. They'll hire you as a full-stack engineer, which means you work across the front end and the back end. That's typically what I do personally. But then you've got roles like developer operations engineers. So you're responsible for all of the deployment process of your large app. And we actually cover a lot of this in this course. You've got security engineers, which we don't really talk too much about in this course, but you're specifically focused on securing the front end and the back end of your application. And then you've got people that test your application or your systems to make sure everything's working. Full stack pays more. I don't know about that. Maybe. And interestingly, actually, some engineers will focus their whole career around one or the other. They'll say, I only am a front-end engineer, or I only am a back-end engineer. Maybe you're specialized, but actually I agree with Free Within Me is his YouTube handle, that you should know enough about the full stack, I think, sort of just personally. And then, so if you look at the course structure of the courses at CSE, you take this course after intro programming, and before maybe you go on to something like 2511. And then you go on to do some other courses. So the stuff you learn here is really important because it's how you can actually solve problems and build large solutions. Okay, so we can get into a bit more content now. Oh, I've got this clicker, I forgot. So we don't want you to be software engineers or an average software engineer. We want you to be really good software engineers. In fact, CSE at UNSW, I know we have someone new from Macquarie somewhere and other places. Who's new to UNSW, actually? It's a good question. A few people, a couple people. Maybe one of the reasons you chose to come here is because you've heard of sort of the reputation that UNSW has at CSE specifically, yeah? And the reason is that we train you to be really good software engineers. Late last year, I got a call from someone at Amazon who was complaining to me that not enough of you were going into their grad program. I mean, that's kind of shocking. At most unis, the students are begging to get into the grad program. And that's because a lot of students here want to go to Canva or Atlassian or somewhere a bit cooler than AWS. But we make good software engineers. You make yourselves good software engineers. But we focus on really modern and important software engineering concepts. So what do you have to do to be a really good software engineer? You have to understand the problem you're trying to solve. This is key. This is really key. A computer scientist often will solve a problem in the way that's most interesting to them. Does that make sense? A software engineer will throw out their ego and make the optimal solution that balances how long it's going to take to build it and like the quality or the performance of it. Good software engineer isn't about writing the most optimal algorithm that solves this particular problem, you know, in the big O notation that is absolutely perfect, because that might take a couple of days when you can write a quick Excel or Google spreadsheet that solves a problem in 5 minutes, right? The first example is a good computer scientist. The second example is a good software engineer because it took so much less time. Now you can go on to the next thing and create more value for your company or for yourself. Exponential type, yeah. You need to design and develop code that resists regressions. What is it? Does anyone know what this means? We'll come back to you if no one else. Come on, someone else has got to. What do we mean by this? Come on, someone give me a hand. Or who doesn't know? Who doesn't know what this means?
Does that mean like you can iterate the version?
Yeah, I guess maybe you're on the right track, I would say, maybe. Someone else? Backwards compatibility is, I think, slightly different, but I think you're a step even closer. I saw someone going like, no, which means you must know. You must have an alternative. All right, we'll go back to...
I only had a guess that it would be as the people who are using the code changes, it can stay relevant, it doesn't become overly complex.
Do you mean like users or engineers? Yeah, that's right. So this is really hard. This is really hard. How do you teach something like this? I don't know. It's really hard. It's hard. There's a guest lecturer coming in a few weeks who maybe will have a better answer than I do on this. Resisting regressions, being able to write code that does this comes from experience and nothing else, I think. I don't really think you can teach it. The idea is that you might have a function that takes 2 integers and it does some calculation to the numbers and returns the sum, let's say. But a good engineer will sit there and think, I can imagine in the future someone might want to pass 2 strings of integers because something else might change in the system. I can foresee that happening, so I'm going to build that compatibility into the function. And now one day someone in the future goes, I don't have integers anymore, I've got these 2 strings instead. Oh, the function accepts it and it works. Rather than having to rewrite all this code because it wasn't supported. That's a sort of a small example, but it's what I'm trying to say. But you can sort of see the conundrum there, like the challenge is that, but I just said that we want to be efficient. So you've got to balance being quick, being efficient, but also being robust, and that's really tough. So this is another tough one. Ensuring software that is safe as possible by verifying that it's correct. So we want our code to work, right? And we want it to work on all the edge cases. And we do that a bit in 1511, and you can imagine as systems get bigger, that's just an even harder problem. And I think this is the biggest point. If you remember anything from these few slides, it's this one. Understanding that the purpose of software is to make it available for users. That says use, but it's the same sort of thing, for users. It's the users that matter most with software engineering. I can't stress that enough. So many times working on software projects in industry, and an engineer will come by and be like, look at this like amazing, I spent like a day on this. There's a specific example I'm remembering of. I won't go into the details, but it was like using this database to track changes in the thing. And I'm like, no user is ever going to, like, we've spent too much time on this. No one's ever going to care. We don't really need it. Like it feels good as a computer scientist to write something like that, but it doesn't make an impact for the users. Software engineering is recognizing that at the end of the day, it's the features that the users use that generate value for us. And then we have to work together in groups of people. I've said this enough. Good software engineers don't always write the most optimal solution. Yeah, and we're going to have a lot of fun this term. So we will take you all through the software development lifecycle process. So requirements gathering, designing solutions, development, correctness, working on projects, coding together, and doing some full stack stuff. So the software development lifecycle, I think if you've done like high school software, does this ring a bell? Maybe they got rid of it or something like that. But it's the overall process that a software team will go through when they're building a solution. So if we've said that the users are most important, we need to be working with our users to understand what they want. So we typically engage through this life cycle. The requirement stage is about understanding the problem that we're trying to solve. So this is really important, and I think this is where most software projects go wrong. You basically, if you do this stage wrong, the requirement stage, you speak to your users and you're not really vibing with them, and you build the wrong thing. So this part's really important. And this is non-technical. You need to know a bit of technical stuff because you need to translate that to your team. But this is about actually listening, not about what you want to build, which is what we often want to do, but about what the user actually needs. And sometimes, maybe even most of the time, depending on what type of lab you are or something, you don't need to build anything at all. There might be a solution that already exists. Maybe you don't tell them that so you can get their money, but I don't know. Design. So you speak to your users and they say, I really need some app that lets me, I don't know, what did I need? I needed like an app this morning that like gets me in contact with the audiovisual team really quickly, right? So then you need to go about and thinking about, so no development at all, thinking about what will this solution look like. And in the design phase, we often do software modeling, which we'll talk about in this course a little bit. And that is basically drawing fancy pictures that describes the architecture of our overall solution. So a simple one could be like, okay, you've got your back end, your front end, the users interact with the front end, there's a database that connects to the back end. You're describing what your system looks like so that if you've got a team of people ready to build, they know what to build and what to get started on. Then it's the development stage, which is probably the fun part, where we actually get onto our keyboards and write some code that solves our problem that we designed. In this course, we're using JavaScript. And then later, actually, we convert into TypeScript, which is probably one of my favorite languages, actually. It's just JavaScript with types. It's a very unimaginative name. And then correctness or testing. So we write some code. How do we verify that it works? And how do we verify in 12 months that it works? When this is the other thing about software engineering, right? This happens all the time. You join a project, let's say, you're looking at some code, and you go, what the hell is this? Like, this is absolutely garbage. And you say to your engineering manager, what is this? And they go, oh, I don't know, like Sarah left 16 months ago and no one knows yet because the person that wrote it left. But if you've got something like an auto test in there that describes what that software does and verifies that it's working correctly, okay, I'm less worried. That happened to me, someone says on the chat. Yeah, it happens all the time. In fact, a funny example of this is if you ever look at the, I think it's the Quake. Has anyone seen the C function for a fast square inverse square root? So this is what, there's this one function that basically makes 3D games possible at the time because they were too slow to do. And whoever wrote it, so no one actually knows who wrote it. It was somewhere at id Software, which is where John Cormack worked. And someone went through later and tried to document what the function was doing. And the comments were like, oh, this is doing this, and this is doing this. And then the next comment was like, I don't know what the fuck this is doing. Like, that's the literal comment in the code. Like, I'm quoting, so I'm... Sorry? I don't know. No, it's I can show it later. It's the fast square root. Yeah, inverse, yeah. But that's the actual comment. I'm a good boy, I'm not swearing. Yeah, this is also really important. And then these systems that we write and that we test, they can't just live physically. I'm not moving anything because something will break. They can't live physically on these laptops. Because a friend of mine when I was at uni was walking past a train station and dropped his laptop onto the train tracks and the train destroyed it. Imagine if like the YouTube source code was on that laptop and that was the only copy, right? We'd be not in a good shape. So typically, the code that we write is only on our local machines for a very short amount of time. Then we put it onto some sort of cloud repository, which we talk all about in this course. And we have to code together. This is like the part that gives everyone, the number one, we get the My Experience reports for our courses. Mine are very good. But when we look at the software engineering ones from this course, the biggest the biggest issue that people have is working together. And it's really interesting because by far the biggest problem in industry is probably politics. It's people in teams that don't get along or something like that goes wrong. And that's just manifesting itself in 1531, I think. And so it's actually really normal. But learning how to be a professional and getting around those problems, and then even learning how to know that those problems are going to appear and learning to become a bit of a leader and solving those dynamics in your group, which some of you will naturally do, and I've seen that time and time again. That's a really, really valuable skill to learn. So if we wanted the highest My Experience sort of results, we'd kill the group project, but that's not the point, right? The point is to expose you to the things that might happen, and it's not going to happen to every group anyway. Most software projects, I think, are web-based now. So you log onto a website. That website connects to a backend. That's the general structure, right? You actually, if you think about it, you use very few local applications on your computer. Do you agree? Most stuff you use is through your browser, which is likely Chrome, right? And that's the sort of projects that that's the major project, is that structure. Front end, back end. How do those two systems communicate over the internet? That's very cool. And the technologies that sort of power those applications. All right, so that is the Firefox supremacy, yeah. That is the sort of the welcome and the overview part of the lecture. By far the most boring content of the year. Every lecture, there's a QR code that appears at the end. You probably saw this in 1511. If you scan the QR code on your phone or something like that, it'll open a form, and you can put some anonymous, or you can put your username or whatever, feedback in the form, and it's really valuable to letting us know how it went. Maybe you'll see if you leave some feedback, I read every single one. Yuchao and I will read every single one. And if I can, we will make sometimes substantial changes to the lecture, to make it a slightly better experience. There's a number of things actually that I changed in my lecturing because of feedback that's come through these forms. So This is just normal. They'll be at the end of every sort of slide deck. Okay, were there any questions on... We're doing good for time, actually. You'd like a face cam? Is there no face cam? Oh my God. There should be. I mean, that was meant to be there the whole time. Yep, first lecture. Cool. Is that better? Online people? I mean, in person, you gotta. Okay, is there any questions on software engineering in general, the course structure, the assessment structure, anything, please? Oh, that's okay. Yeah, so my name's Jake Renzella, and we have Yuchao Jiang over here. We're the lecturers for the course. Sorry? Yeah, we have 2 lecturers for the course, and we're going to alternate some of the lectures. Yep.
Oh, and is the online lecture being recorded?
Yeah, streamed and recorded.
Or will it be uploaded somehow?
Yeah, so, okay, that's a good question, actually. I should talk about this. Thank you, yeah. So, there's 2 lectures a week. The Tuesday one, 10 a.m., you're here today, and the Wednesday, 2 p.m. For all future weeks, the Tuesday lecture is live streamed online only. So it'll be Yuchao or I, probably from either a streaming room or our homes or something, doing an online lecture like you've done for the past year or so. And then the Wednesday lecture will be in this theatre, like this. Today's the exception because it's the first lecture. I wanted to do it in person and make sure everything was working okay. But if you can't make the Wednesday lecture, it's still streamed online. And the YouTube channel with all the links, all the lecture streams get recorded at the end. So they're just YouTube videos. And we'll link them all on the web CMS page. So it's really, really, and as soon as the lecture ends, YouTube takes maybe 15 minutes to process it, then the video recording's up there. But on the Wednesday especially, I really encourage you all, and for those of you online as well, to come in person. Yeah, it's just a different experience. All right, so put your hands up if you've got a question, and then there's some questions on the YouTube chat as well. Okay, where can we find the lecture slides? For all weeks, apart from this week, because I was honestly so busy this week fixing this room with the AV team. We'll put a PDF link on the web CMS page on the lecture timetable. So there'll be the YouTube link and a PDF link, basically. You got the face reveal, that's good. I've got this fancy camera that should, like, in theory, track me. You can't see it in person, but online it's like, can you see the cute little... On a scale of 1 to 10, how hard would JavaScript be in relevance to the course for someone who has no experience? I assume you mean no experience in JavaScript, not with programming. JavaScript is a very interesting and forgiving language. We'll write some maybe a bit today, and you'll sort of see what I mean. It's very C-like. It uses a very similar syntax. And there's a reason it's a popular language. Really popular languages like Python and JavaScript are actually typically fairly easier to write. You'll see, I'll do some programming later, and compared to C, which is what most of you will have experience with, you'll have a heart attack at how different some of the stuff that you can do is compared to C, and how easy it is to do some cool stuff. Other major project groups formed on the tutorial class that we're in? Yes, so your group members have to be in your tut lab. And a lot of you have filled the form out, so we've already allocated the groups. Yep. Yep. The form ended 9 a.m. yesterday.
I just enrolled on the very end of the weekend, of last weekend. I don't have choice.
You still have a group.
I know, but
Do you have a, look, okay, speak to your tutor. We still make changes for the first week.
Oh, really?
Yeah.
Oh, by the way, is there
My God. That's someone you want on your team. That's confidence. That's someone who will go to your project manager and tell them, you've given us too much work this sprint. So whoever's in that... Now, you can't... It's not a free-for-all. They are sort of locked. But if there's someone in your tutorial that you want to be with, I should even say... Speak to your tutor or speak to me after. It's okay. There was a form... Okay, this is another point. I really hoped that... I think I taught a lot of you in... Who did I teach in 1511? Oh my God, a lot of you. How cute. Welcome back. Please install Outlook on your phone and check your emails. Because all of this stuff does go... Maybe some of you enrolled late and you didn't get them, that's fine. But that's a pro tip, Jake pro tip, install Outlook. Praying to the CC gods of my group will be friendly. Everyone's going to be friendly. I've not seen a 1531 group issue that we didn't solve. Yeah, people don't check their emails. Yeah, cool. All right. What time is it? 10:57. Do we need a quick break in 2-hour lectures? Yes? Who thinks yes? Okay, that's a lot of hands. All right. Let's stand up, have a quick break, go to the bathroom. We'll be back if you're online as well. I think we used to do this online as well. Bring the Breville into the lecture hall. Oh, that's cool. Someone needs to bring like a portable coffee maker. If you want to come up and ask Yuchao and I some questions, feel free. That's the benefit of coming to the in-person lectures. There's bathrooms around, whatever. I'll see you back in 5 minutes. 5 to 7 minutes, something like that. Yep.
I need coffee.
Yep.
No, it didn't work like in the first
Let me
lecture.
just
Shall we...
mute my mic. There you go. Now they can hear you. Sorry, we didn't realize, for all of you online, that there was no camera set up. What are the people saying on the YouTube stream? Programming is so much more fun than circuit analysis. I agree. 1511 was the reason I switched to computer science.
Wow,
That's very nice.
that's so amazing.
That was that's my coffee machine.
Oh.
Because they saw it once in the old streams, so they say to bring it back.
Bring to the lecture hall.
Yeah. It's like a coffee machine.
They're talking about.
How's the online stream going? Good? Oh, why did it go blue?
Is it?
Oh, it's because it's tracked someone else. Can we have
Yes.
5 more minutes of break? No.
Yeah.
Maybe
one
one more minute.
Yeah, 1 more minute.
Oh, where's the soda water? I know, I miss it too.
What's
Oh, because
that?
I used to drink soda water on my streams.
Oh, you can have that next week.
Yeah, I'll have to bring
next
some next
Tuesday.
week. How's this camera going?
Where does the lecture hall
Probably doesn't
looks
like 2 people.
You want to know how
Oh,
the lecture hall
what does the lecture hall
Come
look like?
again next
Yeah, come next
tomorrow.
week. Come tomorrow.
Yes, come tomorrow. And
But I can actually... What? I think I can actually show you. Ready?
just actually a lot of people coming in today.
Is this going to work?
Yes, it was.
Everyone's out in the break. Oh, I can't go the full way around.
Well, this is so.
5 minutes and no. Please say yes to 10 minutes. Did I used to do 5-minute breaks or 10-minute breaks?
It's at 5 to 7 minutes.
No, but I'm saying what did I used to do? There you go, there's the lecture hall.
Oh, I love this camera.
Yeah, it's cool. Then I gotta go this way. It'll probably end up being, oh,
Yes. Here we are.
oops.
Alright, I think you need to start again.
Yeah,
Oh,
we'll let people, thank you. We'll let people come back. Okay, go away. Woo. Hey,
I had a little bit trouble with the CSE connection. Like when I try to create a folder, it's only throws me an error like this.
I don't think you can use this extension with CSE. I think
So,
you can use VLab or WSL or remote SSH. It's called, I think, the extension.
download a lot of this.
Yeah, that one I think works. Maybe
Actually, the download is into my laptop.
that's installed already.
Yeah, it's
So you
already-
should be able to connect via this. But you'll probably need to post in the forum and we'll get you help. One of them, I can't remember which one of them is disabled because it caused issues with CSE, but one of them does work. So there's actually a guide. If you go to Google and search CSE remote, oh, that's it, this guy.
Yes, I follow
Is it
this
not
guy.
working?
Yeah, it's not working.
Find the part that's not working, post on the forum and we'll get you help.
Find the part is not working.
Yeah, like at what point did it stop working?
Yeah, like put this error. Why is not working? This like error to some
Delete all these other extensions. I think that's what it's trying to say. But I'll have to have a look another. We'll have to look another time. Yeah.
I'll ask people to come back to the system.
Yeah. I mean, if they're back, I guess.
Hello, we are starting again. So please have a seat.
Okay, cool. So I think you can hear me online again. And you can hear in the room. Yep, awesome. Okay. Yeah, I know. Yeah. Yeah, there's an upstairs, but they won't let us go up there. It's very sad. Okay, AV is good. Great, thank you. Okay. let's go back here. It may be possible that the video covers some of the slides, so let me know if it's too big. Okay. All right, that's enough sort of talking. Now we can start getting into some technical stuff, which is good. So I definitely, I'm going to do a bit of JavaScript live coding just to sort of show off the language a bit. But I think before we do that, I'll introduce it via the other thing that we're mainly looking to talk about today, which is Git, which is a very funny word. But so let's how do we introduce the reason why? Whenever I introduce something, I like to take a step back and think, what was it like before this thing, and why do we have it, right? So far, if you think about 1511, right, this is or intro programming, wherever you've done that. So far, you've written code on your own. Does everyone agree with that? Like maybe you spoke to someone, you got help. But it was you on a keyboard with a problem, you write the code, you see if it runs the auto tests, and you celebrate. So far you write code on your own, but as we've spoken about today, when you write in teams, you're not on your own. And that actually, it's very nice to be able to work in teams. We can get a lot more done. But it introduces a problem. Things can get messy. So if you think about, imagine you've got like a program. So think about like the assignment from 1511. Remember you did some linked list stuff? Imagine you're in a team and you've said each of you need to write one of the functions in your linked list program. So you say, okay, Yuchao's going to write insert node, I'm going to write delete node. Yeah, but also at some point someone needed to define the actual node. And then let's say I come along and I'm working on this program and I realize there's a bug with the node sort of declaration, so I go off and fix it. But Yuchao has the code from before that fix. So she's working on this function, right, with the wrong assumptions because she's got the old copy of the code. Do we sort of see the problem? And then we both write our functions and we meet up and we have to mangle the code back together, and we realize that all of Yuchao's code assumed that the node was declared in a way that it's not declared for me. And now none of our code works. So we've gone from a function that does some things to some program that does nothing now. And this is what I mean. And this is just the tiniest example. Now imagine you're Google with thousands of developers on a single project. How the hell do you do that? And this is an open problem that Google and everyone is still working towards to make it a bit more efficient and all of that. Wrong keyboard. But there are some tools that make this collaborative development easier. And by far, so back in the day, there were other tools. Git actually is a fairly recent development. I think, who knows the year? Who knows who made Git? Who wrote Git? Linus Torvalds. Do you know why he made it? Do you know who Linus is? Come on, please. Please, computer science students. Yell it? Yeah. So Linus Torvalds wrote Linux, right? We all know what Linux is. Not Linus Tech Tips. Linus, you know who he is, Jesus. So Linus Torvalds writes Linux. He writes an operating system that is now the most prolific operating system. It's everywhere. It's not powering MacBooks actually, but it's powering all your Android devices. Probably these projectors are running Linux in them somewhere. Most devices, other than Windows machines and Macs, probably running Linux of some variant. So he's writing this massive operating system that's very, very popular, and he comes across this problem again. Like many people before him, he's struggling to coordinate with all the other open source developers contributing to Linux. So do you know what he does? He takes a break from Linux and he writes Git, and now Git is like one of the most widely used software projects by developers. So that just speaks to some of the genius of him. Before Linus wrote Git, there were other solutions to this, but clearly history has favored Linus because Git is by far, I mean, I don't think anyone uses anything that's not Git anymore, unless it's it's like legacy and it's stuck around, but there's not even a point talking about them. 5-10 years ago, you would still, if I was giving this slide, you would still sort of introduce these other systems, but there's literally no point. Everything's using Git. So Git is a version control system, or a VCS, and the idea is that think about like a Dropbox or a Google Drive, but specifically for text files, so for code. And you could use something like Google Drive. In fact, I remember when I was like in first year, I kind of did actually. I would write code in a Google Drive folder and it's like, oh nice, it's backing it up. But if you think about Google Drive, what it does is it backs up the entire file one version at a time. Does that make sense? So I can go back to the file that was yesterday and I get that version of the file, but it's the full file. What a VCS does, or what Git does, is it can actually track specific lines over time. So if I edit a function, just that change to that function gets updated. And it allows for concurrent programming. So it allows and supports multiple people, 5, 10, 1,000, working on the same file at the same time on their own computers. And then it even helps us merge all those changes into the one, final version or whatever, seamlessly integrating the changes together. It is by far one of the most important tools you'll ever use as a software engineer, other than obviously like your compiler and stuff like that. Every piece of code I write, unless it's like a script for a lecture, is a Git repository, right? It's just so prolific. And this is the course that we teach you Git. Interestingly, most unis, maybe now it's a bit different, most unis don't even have a Git. I don't think they really teach Git as part of the main curriculum, which is shocking because it's everywhere. Maybe they're better now than when I was at other places. I mentioned this Dropbox OneDrive thing. So yeah, Git is a version control tool that enables people to work concurrently, and it's built for programmers by programmers. So that's what differentiates it from something like Google Drive or Dropbox. It's made for source code for files, text files. This is now where it starts getting a bit tricky, but it's really, really important to understand this about Git. So it's distributed. This is what really differentiated Git from other solutions, and actually this is what made Git win out. It's this part of it is the reason why when you go off into industry, you'll use Git. This is the magic, not magic, but this is the key. It's distributed. What that means is, so early versions of source versioning control, you had the idea of this like master repository, or this main repository now is like the industry is moving away from that term. And basically it's like, let's say I'm leading the project, my computer was like the main source, does that make sense? And then Yuchao would would network into my computer and sort of branch off that. Git said, no, that's the wrong way of doing it because you're still reliant on this one machine as the source of truth. So Git said, make no machines, no single developer the source of truth. Have it be that everyone is the source of truth. So it's distributed. Everyone has the master or the main repository and their own branches. And what that lets you do is that when you have a cloud, which is what all Git systems have now, that cloud can also be one of your repositories, which means that's how we handle the whole sort of backup problem. This sounds very theoretical and probably doesn't make much sense, but you'll see when we actually use the tool what that means, how it works. So this is the key again. Each user, right, every developer on the team has a full copy of all the work, and therefore each user has a full backup of the work. So if I have a repository with Yuchao again, and I throw my laptop off the balcony up there that they won't let us onto for safety reasons, I can't imagine why, it doesn't matter at all because Yuchao's got the full backup of the system. In fact, if you fire all of your developers and you've got even just one of these distributed Git repositories, you've got the full backup of code, as long as you've kept it up to date. So this is what made Git very popular. And this is the other thing that causes a lot of confusion. So Git itself, Git, is a command line program that runs locally on your machine. There's no user interface, there's no website. Git is Git. And that's the tool that Linus Torvalds wrote. And then I mentioned this idea that you can have these repositories sort of scattered around. So companies came along and said, well, we're going to make a service, a cloud website, that is one of your Git repositories. And then I'm going to make a browser UI that lets you sort of interact and manage it. And that's what these things that you've probably heard of as well are. GitHub is by far the most prolific, probably. There's Bitbucket, made by Atlassian, which is an Australian-based company that a lot of you will go and work at, potentially. They hire a lot of our grads. And GitLab, which is actually what you'll be using in the course. So basically, think of them as like non-developer Git repositories that have like a user interface, so you can actually see on the browser the different code files and all of that. But they are like extensions of Git. You don't need these to use Git. Sort of. You sort of do in practice. So let's get started. I'm warning you now, Git is one of these things where it'll take you like the full term, maybe, to get like your head around it. And then it'll take you even longer to like really, really get it. Maybe some of you have played around with it a lot. The concepts are like very unintuitive sometimes. Like the way that the Git is structured is confusing, I think. But it's clearly a very good solution to the problem. And it's a hard problem, so the solution this is what's sort of worked out. So, no more slides for now. So I mentioned that we use GitLab. So this is, most of these Git services work like this. In fact, if you've already gone through Getting Started or the Week 1 lab and you've set up GitLab, you can follow along if you like, but you don't have to. So what a repository is, or a repo, is a directory of code. We call these repositories. And this is where all the source files live for a particular project. What I'm going to do is go to let's go home, my GitLab. Personal repositories. And what I'm going to do, actually, let's not do that. Let's make a new one. So I'm going to make a new project, and let's ignore that security error. I'm going to make a blank project on GitLab. Now, for your labs and assignments, we actually make the projects for you, but I'm just showing you sort of end-to-end how this works. So I'm going to go to this GitLab. So think of GitLab, right? This is like a computer in the cloud. Actually, we host them at CSC ourselves. And I'm going to make a repository. I'm going to make a Git repository of some code. So I'm going to call it, 23T1 lecture science theater. I can't put exclamation mark. Cool. That's a really bad title, but that'll do. I might just get rid of the spaces. Okay. Then I'm saying I want it to be in my personal repository. Again, you don't have to really worry about this. It's just because I can manage all the repositories, so I have this setting. And that's what I'm calling it. I'm going to make a private repository. I'll talk a bit about this in a second. And then I'm just going to tick that, put a README file in the repository. So it's going to start the repository with a file. And then you can see there is this directory, this folder of code. There's only a single file in there, and it's got this README document. And the README document's just got some text in there, basically. So it's just created a file. What I want to do now, right? So this is like, you can think of it like this is on the cloud. This code is sort of saved. And now I want to get this project onto my local machine. I want to take it from the internet or from the cloud or from the server and work on it locally so that I can write some code. So how do I do that? Well, we clone it. So this is the first piece of Git terminology, the clone. And the clone is very simply clone the repository from the remote server to the local server. The way that we set up authentication with GitLab is the SSH keys. So I'm going to copy this SSH URL. And you'll all do the same thing when you clone your repositories. So I just click that button to copy the URL. Everyone following so far? So far, all I've done is click a couple buttons. Then I open my terminal of choice. And you've all used a terminal, right? Yes? So this is all familiar. And remember you used DCC to compile your programs, and maybe you used CD and PWD, right? There's these programs or these command line tools to do stuff. And remember I said Git is a command line tool. And if you're on VLab or the CEC machines, Git is already installed on your machine. If you're running on Macs ship with Git as long as you turn on the developer tools. And if you're on a Windows machine, Windows sucks, so they don't ship with Git. But they finally fixed it with WSL, so you've probably seen some of that on the forums. So if you're on a Windows machine, I really, really recommend you use WSL2 as your development environment, which if you don't know is just putting Unix right on Windows by running Linux. So Linus is happy. So then I've just gone to my, can you see the terminal? So then I go to my terminal, I'm in this directory. In fact, why don't I just, when you open a terminal, you're typically in like your home directory, right? So I can actually decide where I want to clone down that project. And for me, everyone's different. I have a directory called repos, so repositories. That's a top-level directory on my Mac. This is pretty common, what people do. So this folder contains all my different Git repositories. So I can change my directory into that repository. I can have a look at what's there, and you can see some of the projects. Hopefully there's nothing that shouldn't be there. You can see some of the projects, the Git repos that I've cloned. And this is a fairly new machine, so it's only stuff that I've cloned since I've been working on them. So every one of these is a Git repository of some project, right? Could be a research project I've worked on or a development project or whatever. I've got a folder called COMP1531. I'm going to go into there. I'm going to go into 23T1, right? You can decide where you leave all your code. And I've got this lecture code directory. I've got this week 1 directory. I'm really nested. And I got some files there. But that doesn't matter. I can clone the directory down into this folder. So how do we clone? Does anyone know? Yeah, who would have guessed? Yeah, exactly. So I can make this a bit bigger. Is that better? So git clone is the main part to do a clone. So all Git tasks, you need to run the Git program, right? So that's the Git part. Oh, look at this fancy thing I got. That's the Git part. And then the clone part is the action I'm taking within Git, which is to clone down some repository. What do I put next? And my terminal's already trying to be a bit clever and suggesting something. But what do you think I would put next?
Like the direction of the file.
The direction? What does that mean? Yeah, the link I copied, right? So that's the public identifier of that repository. I say public, it's not actually public. I chose to make a private repository, right? So that means I need to prove to GitLab that I am Jake Renzella and I have access to this repository. The way I'm doing that is with a handshake with my SSH keys, and that's sort of described in one of the lab 1 task. I think you'll set that up as well. I've already set it up. So what that means is I can just paste that URL, and that's it. This command is going to execute, hopefully, if it all works, and take the folder, that repository, and download it, basically, clone it down. And it's going to put it in a folder in that directory. So I hit enter, and you can see it says cloning into that folder name. Okay, I have a password set up on my SSH key, but you probably won't, actually. And then you can see there, it cloned it down 100%, all the files came down and all the information came down A-OK. So that means if I list the things in this directory, what we can see new is this folder. And remember, that's the name that I called it on GitLab, 23T1 Lecture Science Theatre. Remember I typed that in just then? And so what do we expect will be in this folder? Anything? The README, because that was what existed, right? That's what existed in the repository when I created it. And what I can then do is open this folder in my development environment, and I use Visual Studio Code, which I think a lot of you now maybe use, depending when you took 1511. And this is just the GitLab added this content. Basically, I didn't add this. But this is the first thing that we do with Git. We made a repository externally, and we cloned it down. And now I have access to this repository. And now I can throw this machine. Where could I throw it? The train tracks, or I could, I don't know, into those fountains we've got or something. I could destroy this machine, I could go to the Apple Store, get another mortgage and get another one, and then clone it again, and I've got all the files. I don't care. So no more excuses. This is actually your downfall, because you can't say, oh, Jake, I lost the files or whatever. You don't have to set up a passphrase for the SSH key. That's OK. I had to do it for some other reason, I think. I don't think anyone is going to steal your machine and use it for your 1531 stuff. They might. You never know. Cool. Cool. OK, so that's sort of step one. This is just, though, to get started, right? Now I want to write some code. So I can delete what's in here and say, my awesome project. Maybe let's make it a bit bigger. Right, my awesome project. This project will show all our 1531 students how cool JavaScript is. That's the if you've never seen a README file, the whole point of it is to describe what this repository is trying to do and how to use it potentially. They're very commonplace. I can show you at the end of the lecture some of the other README files and other projects in my other repositories if you'd like. So you're just trying to communicate to other developers who clone this repository what's going on. All right, so I can say that. In fact, this already brings us to our next point, which is that what's happened, what's going on here? Who can guess where I'm going with this? Yeah, someone else? Yeah, that's correct. You're correct, but anyone? Front row? No? Can you guess? Well, let me show you, right? Let's go back to GitLab. Let's refresh here. This isn't what I wrote, right? What I changed, at least, locally. We agree? So I'm sort of stuck, aren't I? Because what happens if I destroy this machine? Sorry? This is out of date. This is out of date. What's on the remote repository, it's not like automatically kept in sync 24/7 without doing anything. I have to tell Git, hey, I've made some changes locally. You need to take my new changes. Right? All I did was change this README file here, but you could, whoops, not that one. Or that one. or that one. Where did it go? Oh, there it is. All I did was change this README file, but you can imagine I might have spent 4 hours writing some code that I really don't want to lose. So this is the second Git operation that we need to cover, and that is taking my local Git repository, and the term is pushing it up to the remote one on GitLab. So I've got some new changes locally. It needs to go up to GitLab, and I've already not buried the lead, but the git command to do that is push, but, and here's where Git starts to get a little bit nastier. I can't just push, if I do, like let's do that, git push. What's this going to say? Oh, it wants my passphrase again. It says everything up to date. That's clearly not true, do we agree? Yeah? We agree? It's not up to date? Because I've got this change, and remote has this change. And I can refresh to prove it. So clearly that didn't work. So what's missing there? What's missing is that before I push changes, I actually need to tell Git what I want packaged in this change. The reason we have this will become clearer when you have lots and lots of files. But basically, I need to tell Git, I want the README file changed. And the way we do that is with add. So if I look in the directory, we've got this README file, and you can, I don't know if you can actually see. Do you see it's slightly yellow? Or something like that? Any excuse? Do you see that's like a yellow? Maybe you can just see it. That's telling me, like my terminal is saying, this file has changes, but they're untracked. Git status is your best friend. Git status is a command. You should write this down if you're taking notes, but we'll release the PDF, but it's good to do it and take the notes. Git status is probably the Git command you'll run the most, and it's just it's asking Git to tell you what the status of your repository is, and the status is saying here, you've modified readme.md. I agree, I have modified it. But these changes are not staged for commit. Changes not staged for commit. So it knows, Git has tracked that I've got these changes, but it's saying you haven't told me what you want actually to push up or to track the change. And it's even telling me now, Git's getting a bit friendlier, use git add file to update what will be committed. And the term commit means ready for push. It's a package of changes ready for a push. So what are we going to write here? What's our command going to be? Yell it? Yell it? Git add what? README, exactly. Add the files I want to change. Git add, and I can just hit tab there, readme.md. I hit enter. No output is a good thing, right? So, and again, what can I do to check the status? Yeah, who would have thought? Git status, and now it's got some different output. It says, you have some changes to be committed. Use git restore staged file to unstaged. So that means if you want to undo that, but we don't want to undo that. So if I had multiple files here, I could decide which files I want packaged up. No. The Git command line program right now is not communicating with the remote server. It's all happening locally. Remember, I've got the full local version of this repository, a full clone of it. What it's saying is it's identified there were changes to the file, and I've added that change. So I want to commit that change. Yep. Okay, now we come up to the next terminology, and this is why Git's challenging, because there's lots of terminology, and that terminology is commit. So who knows what a commit is? That's not a hand. I know some of you have used Git before.
Commit is the final stage of saying I now want to merge my changes that I specified to add
Yeah? Down here, you had your hand up? Yeah? Yep. So let me repeat. If you are saying that, yeah, I'm ready, like this code is good, I'm happy with where it's at, I'm ready to get it onto the remote server, which is true. There's probably other ways of putting it. What a commit is, and we talk a lot about how to write good commits, because there's good ways of forming commits and bad. But a commit is, if you've got multiple files, you're making a new version of your program, basically. And that might mean adding multiple files. But a commit is like a package that is ready to be sent. So what do we think the git command is to commit some changes? Git what? Yeah, exactly. Git commit. And now this is where we need to do it thing. So every commit has to have a description. A description is just a sentence that describes what's in this commit. And the way we can do this, there's a couple ways to do it, but the most common way is to do this -m, so git commit. I love this thing, I just bought it. Git commit, oh, that's really hard to see, isn't it? Hello? Oh, that's a drop down. Oh, no, there it is. Appearance. Is that better? Everyone loves dark mode. Oh, what? Dark. Tick. There we go. Git commit -m, and then I give it a string in double quotes, and I'm describing what I've changed in this commit. What did I change in this commit? Updated the README file. I can say something like that. When you go and work in industry, wherever you work, your team will have a protocol for how you form your Git commits. The way I was raised, I guess is the term, is that Git commits should always be a verb in the singular tense or something. So, in fact, so that actually I lied there. That should be update the README file. So, the way I always was taught is that you should read, this commit does, update the README file, if that makes sense. So you should read that line and have a quick glimpse of what the changes in this commit were, and then I can hit enter. And it's saying, look at this. Git is an amazing system. It's very impressive. So it's gone, one file changed, the README file, right? 2 insertions, 91 deletions. What are those numbers referring to? The lines in the file. So Git is keeping track of every single line, and if I just changed one line in the middle, it would know only that line changed. And even more impressively, if I pushed that change up, it would only push that line. Like, it knows that it doesn't have to send the full text file. It's pretty cool. Okay, so I've added the file, I've committed the change, I've given it a description. Now I can, let's do another Git status actually, it's always good. Okay, this is interesting again. Your branch is ahead of main by 1 commit, because I made a commit, right? I made a commit locally that the remote server does not have. Right? So, Git is aware of that fact. So it's telling me, you've made a change, use git push to publish your local commits. So what are we going to type into the terminal? Yeah, git push. Git push, and I think if I don't put anything else, that's going to be enough. So this commit gets packaged. I don't know why it's taking so long. Okay, that's why. This won't happen to you, this passphrase thing. I'm going to have to fix that. Okay. And it's told me basically some information that it's pushed it to the remote repository. So now, if we go back to GitLab and we refresh, that's our change. What a lackluster response. Yeah, no, you don't have to clap. No, but this is really cool. This is really cool because, you could be in Antarctica, as long as you've got an internet connection, you can take the latest code from your team and push your latest changes. I've published Git commits from trains and sometimes even airplanes if you're lucky enough to have Wi-Fi on there. This is what has enabled massive productivity gains with software engineering, with the internet and stuff like that. All right. So you got to remember to write your changes, add the changes, commit the changes, push the changes. So clearly a lot more steps than cloning. But when you use this every day, this is like second nature? Is that the term? Okay. Why don't we actually write some actual code, show everyone some JavaScript for the first time, and commit and push those changes up, okay? So why don't we actually, to really sort of demonstrate what JavaScript and what modern higher level languages are like, let's take us back to 22T1, 2, or 3 and write some C code again, a trip down memory lane. So what do we want to do? Make a function that, adds a couple of numbers? Hello world? Oh, we can do hello world. That's okay, you're right. Yes, I taught you well. Our first program should always be hello world. So how do we do this in C? Remember we go int main. Sometimes we do this void here like that, right? And then actually I've already forgotten something. What is it? Yeah. Send it in. No, send it IO. Oh, is it? So I include this library. Okay, then I can. Oh God, Copilot. I've been caught. Int. No. Oh, I just turned it off. Do you? Okay, printf. Hello, COMP1531 students. Can you read this online okay? Yep. Semicolon there, tab that in. That looks about right, I think. We can test this by opening up a little terminal here, clearing that, and I can go gcc program.c-o program. Compile that, I run this, and I get hello comp1531 students, and remember I need to put a \n for the new line, blah, 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 blah. Hello comp1531 students. So that is the simplest, basically the simplest program we can write. Let's make a new file, program.js. Is this anyone's second language? Well, that's a stupid. Is this anyone's second language? That got a laugh. Learning your second language is one of the most, I think, I don't know, I was going to say beautiful, but it's very soppy, but it's a really cool time because it's like now you get to realize how much you know about C and how much you know about programming. Does that make sense? And you'll be surprised at how much you know about programming and not just C. All right, but JavaScript is actually quite different. Who wants to yell some differences between C and JavaScript? It's weakly typed. Yeah, correct. Yeah, very differently. So we just said variables are different, which is a bit vague, but absolutely. Variables are very different. We'll talk more about that. Yeah, exactly. It's an interpreted language. What does that mean? You don't need to compile it, that's right. And that's like, what? How does that work? So you write C code, we wrote C code, we ran the C compiler. The C compiler is another program that's written in C, actually, does anyone know? So it's like, how did that happen? That's weird. But that's a program that takes the C source code that I wrote, turns it into machine code, which my CPU can actually execute, basically. But JavaScript doesn't work like that. How does JavaScript work? What does it mean to have an interpreted language? Python is another interpreted language. What that means is the interpreter, which is just another program again, actually turns the JavaScript code into an intermediate sort of, think of another like a mini language that gets sort of executed in real time. What this means is you don't have a compile step and an execution step. There's just the interpreting step. So that's a huge difference. And you'll see that play out in a second. Any other differences? There's many, many. Another difference is that you don't need a main function. Well, there's no print function either, or printf. Does anyone know what we use in JavaScript? Yeah, console.log. That's it. That is a hello world program in JavaScript. I use the node interpreter to run this program, and I pass it program.js, and I get hello COMP1531. There's no main function. There's no import statement. It's just console.log. Pretty cool? Yeah, it looks very complicated, exactly. Imagine in C I wanted to have a function, or that adds two numbers or something like that. Let's do something like that. How do you make a variable? That's a better place to start. So what would you have to do in C? You'd have to go like int x equals 15, something like that, right? Again, geez, maybe the AI is becoming sentient. It's like, I must help you. In JavaScript, there's actually a couple ways to define a variable. What you should do is use the let keyword. Let x equals 5. This has made an integer called 5. What's the big difference here compared to C? Yeah. Yeah, maybe I'll go to every single person. There's such a massive change. In JavaScript and in Python, you don't have to tell the language what the data type of the variable is. So how does it know what to store here? Anyone have a guess? Well, in this case, what it's doing is it goes, well, Jake, you're assigning it 5. 5 is an integer, so I'm going to guess x is an integer, and it guesses correctly. So if I want to print this, what do you reckon we do? Well, this is the big question. And this is where most people struggle with JavaScript. It's a good question. But let's just try console.log x. And we get 5 printed out. Can you do this in C? I mean, of course you can do it in C, but can you do it like this in C? I mean, we have to do so much rubbish in C. We have to say that x is an integer, then we have to import standard IO, then we have to printf. We can't just printf x, right? We have to printf, if you remember, %d, comma, space, x, right? All that rubbish. Because I need to tell printf that I've given you an integer. Whereas JavaScript is like, oh, mate, I know x is an integer. I can do that for you. In fact, what's really cool is that I can say like, hey, I can mix strings and integers just that easily. Whereas again, in printf, I would have to say %s, %d, blah, blah, blah. Say that again, louder. Oh, yeah, yeah, great point. In JavaScript, semicolons are optional. So I've just forgotten. Or you don't need them. And again, it's probably, in some cases, better to have them. And typically, you'll have a specification that tells you in your job, we want semicolons or we don't want semicolons. Yeah. But in JavaScript, which is yet another change, they are optional. Yeah, I double spaced it by adding that space there. Do we need semicolon? Cool, cool, cool. Okay. What's another really, okay, what's another way to blow your mind? Okay, here. Rather than say x equals to 5, I can actually say x is equal to an array of 5 integers, and I want to print that out. That x now is a variable that stores an array of 5 integers. In C, do you remember what you'd have to do? Int square bracket 5 square bracket x equals curly brace 1, 2, 3, 4, 5 curly brace. And to print it out, what do you need to do? You have to have a for loop, and you got to do this, and you got to do that, and then you got to recompile your kernel because something, you know. I mean, that's, you know, look how cool that is. And then I can even do something like, you know, for what do you do? Do you go like let y in x? Is that right? Is that Python or JavaScript? I can't even remember. No, that's not right. Oh no, whoops. Yeah, print is Python. Console.log is. Whoops. Look at that. So that's my for loop going through each number in the array and printing them out. But JavaScript's even cooler. I can say, after doing that, x.concat additional arrays or items to add to the end of the array. So I can add 6. Let me do it there. Oh, that didn't work. Is it add? Or is it push? What is it? Can someone remind me? Push, 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 push. Well, see, I know programming, not languages very well. Why is it not coming up here? But it's coming out there. Sorry? Oh, that's printing the keys. I think you're right. Yeah, very good, whoever that was. Who was that? Yeah, nice catch. Yeah. Yeah, I was going through the keys of the values, not the actual values themselves. And so in one line, so this is not just an array, it's a dynamic array. Yeah, you can, but let's not do that right now. But the point I'm trying to make is that JavaScript is so flexible. Do you agree? It's so quick and easy to do stuff like this, whereas in C it's a lot more effort. Oh, we're almost done. Okay, last step. We've made some files, right? We've made some changes. What do we need to do? Because I'm very clumsy and I might drop this on the light rail track on the way home. What do I need to do? I need to get my code locally, and in this case now it's 3 files. And this actually is a good sort of demo. So I go back to my terminal, I type git status, our best friend. It tells me I've got 3 files. Now, I've got the program.c file, we know what that is. I've got the program.js file, I know what that is. What's that program with no extension? No, it's not a text file. It was when I compiled the C program, it created the executable binary. Do I want to commit this? Do I need to back that up? No, because I can compile it again. So I want to add the JavaScript in the C file, but not the executable. Does that make sense to everyone? So what do? Git add program.c, and I can just add program.js. I can add both. But not the program executable. And that's why it's still red. So those are green, that's red. Very simple. So now, if I run git commit, what will be packaged in the commit? What will be packaged in this commit? And what about the executable? It's not going to be packaged. I commit that, I run status again. You can see program is still untracked, but the other two files are tracked. What do I do next? Oh God. And there we go, that gets pushed. I go back to GitLab, I refresh the page, and there's my program.c, there's my program.js, there's the code I wrote. You can, now someone else can copy this down and keep playing around, and when I trip on the light rail and like destroy this laptop down into the Randwick race course and the horse like steps on it, it doesn't matter because it's backed up to GitLab. And that's the basics of writing JavaScript, but it's the basics of using Git. And really any project you work on in the future ever, in any course, in any solo project, use Git if it's going to last more than a week or two. Not every single line of code you write, but you're going to want to use Git. Okay, thank you all so much for coming to the first lecture. I will see you tomorrow at 2 p.m. There's the CSC Sock barbecue is at 10 a.m. Is that right, tomorrow? I think so. So there's free food at 10 a.m. and then directly after you got the lecture. It's a perfect day. So I'll see you tomorrow at 2 p.m. Thank you, thank you, thank you, thank you. Thank you. Thank you online. Is that still tracking? Thanks.